What's up, everyone? Welcome back. Patrick here. Moving on to the next question in the Unit 1 Advanced Functions test. Here in this example, we are given three functions and we have to determine whether they are odd, even, or neither. Now, as usual, what I recommend, pause the video here at the beginning. Try to do this yourself. Even if you're not getting it to the final answer, or if you get stuck at any point, still try to go through the process, still try to go through the grind. I know sometimes it could be a little bit frustrating if you're not getting it, but just going through it is going to help you retain the information a lot better once you watch the video, once you watch the solutions after, and you kind of want to go through this frustration now versus later on when it actually matters when you're writing your actual test. So for all these questions, I always mention, try to pause the video, try to do it yourself, and then watch the solution, and then compare your process to mine. So starting off with part A, we got f of x equals negative 4x cubed plus 3x. Now, just as a quick review, hopefully you know this by now from the lecture videos, that if we're going to have an even function, we know that f of negative x has to equal the original function, f of x. And then if we're going to have an odd function, we know that f of negative x has to equal negative f of x. Right? So we got to check if any of these cases here are met with this function, and if neither of the cases are met, that means the answer is neither. So you always want to check to see if it's even first, because f of x we already have, and then f of negative x we're going to be using in both of these anyway. Right? So you always want to check if it's even, because once you get the f of negative x, you can then see right away, is it going to be equal to the original function? And if it is, then it's even, and you don't have to go further. So let's first check what's f of negative x going to be. We got to get this expression. F of x we already have. That's just the original function given as is. Now we got to find what f of negative x is going to be. So what we would do is we would plug in negative x for all of these x values here. So we'd have negative 4, negative x to the power of 3, plus 3 times negative x, like that. And so from here, you basically want to simplify this expression as much as possible. Now, negative x cubed, that's just going to be negative x cubed, like that. Because what happens is, if we have negative x in brackets, that's like a negative 1x, like that. There's like an imaginary negative 1 right here. And then what would happen is the negative 1 would go to the power of 3, and then x would go to the power of 3. Now, negative 1 to an odd exponent, it's always going to be just negative 1, and then we're going to have the x cubed, like that. So if this was negative 1x in brackets to the power of 4, we'd end up getting positive x to the 4, because you'd have negative 1 to an even exponent. That's always going to give you positive 1. All right, so that's going to be negative x cubed right there. And then 3 times negative x, there's no exponent to worry about here, so we could just multiply these right away. That's going to be minus 3x, like that. And then negative 4 times negative x cubed, that's going to be positive 4x cubed minus 3x. And so notice that we have our expression for f of negative x. So let me erase some stuff here. Let's get a little bit of room. So notice that f of negative x, this that we just got, does it equal the original function? Well, no, it doesn't. Right? We got a 4x cubed. Here we got a negative 4x cubed. And just that alone right there is enough to see that it's not going to be the same. But we also have a 3x and a negative 3x. Right? So this condition for this particular function is not met. F of negative x does not equal f of x, right? And so the function, we for sure know it's not going to be even. And so now we got to check this other scenario. Does f of negative x equal negative f of x? So what I'm going to do is I'm going to take this and I'm actually going to shift it up here just because we're still going to be using it. And then all of this stuff here, I am going to erase because we still got to find what is, let's kind of split this off here. We still got to find out what's negative f of x, right? We got to see what this expression is going to be. And then if this expression, f of negative x, is going to equal negative f of x, the expression we're about to simplify, then we know it's going to be an odd function. And what you do here is you pretty much just put the negative outside and then you put the function in brackets. So we'd have a negative on the outside, put the function, the original function in brackets, we'd have negative 4x cubed plus 3x. Well, this one is easy. All we do is we just distribute the negative inside the bracket. All of the signs change. Sorry, that would be minus 3x, like that. And so this expression here is negative f of x. And notice this negative f of x and f of negative x, they're the exact same thing. So we know it's going to be odd. Now moving on to part B, we got f of x equals 2x to the 4 minus x squared plus 4. Yo, what's up? Quick little intermission here. Wanted to mention a few things quickly and we'll get right back into the question. First off, if you are getting value from this video, if you can please like the video and subscribe to my channel, it does help me out a lot. Number two, if you're watching this on YouTube, you can go to the description box and there is a link that will take you to my website, allthingsmathematics.com, where all my courses are organized so you can watch the videos in order, and I'd recommend doing so because lots of concepts carry over from one video to the next. Also, for lots of the courses, at the end of the chapters, you can find tests that you can practice with, and the tests have video solutions as well. Number three, if you feel like you need personalized help and tutoring, give me a shout. I currently tutor students 7 days a week over Zoom, both high school and university students, one-on-one and in groups. You can text me. We can discuss availability and then we can book a session. My contact details are on my website. And lastly, feel free to forward the website to any of your friends who are also taking the course, who you feel can benefit from these videos as well. Hit me up on all my socials. It's All Things Mathematics for all of them. Back to the video we go. And again, same process. Is it even or odd? Well, f of x we already have. Let's find an expression for f of negative x. So again, same thing. We just plug in negative x for all the x values. Just make sure that you're putting it in brackets like that into the original function. And notice now we're dealing with these even exponents. So I'll do one of them on the side here. Negative x to the power 4, that's going to be like negative 1 to the power 4, x to the power 4. Negative 1 to the power 4 is just positive 1. So you just end up with x to the 4. Right? So over here, this would just be x to the 4, right? The negative would go away. And then over here, you'd have minus, this minus, but then this negative x to the power 2, it's an even exponent that just stays as x squared. If this was x to the 3, it would turn into negative x to the 3, and then the two negatives would turn into a positive. But here, we're keeping this negative right there. This turns into a positive x squared. And then we have a plus 4. And then there's nothing else we can really do to simplify. So what's the first thing we check? Does f of negative x equal f of x? And notice that in this case, it does, right? F of negative x, what we just simplified this to, is equal to the original function, and therefore we know that this function is even. And then finally, moving on to part C, we got f of x equals sine x. Now, this is one of those where you should just remember it from the unit. You just have to kind of know it. It's hard to do it algebraically. I will show it to you algebraically after, but you have to know trig identities to prove it. And trig identities is going to be covered later in the course. So another way you could show it is graphically. So remember, an even function, it's going to be symmetrical about the y-axis, versus an odd function, it's going to have point symmetry. It's going to be symmetrical about the origin. If you remember, sine x starts at the origin, and it looks something like that. Keeps going on forever. I'm just going to make it go up to this point here for one cycle, and then the same thing happens here, like that. And so remember, with an odd function, what we could do is we could reflect it in the x-axis and then reflect that in the y-axis, and we should get the other half of the graph, which indeed does happen here. So sine x, it actually has point symmetry, and so this function is odd. Now, in terms of seeing whether this algebraic expression is satisfied, there is an identity where sine of negative x is equal to negative sine of x, like that. There is an actual identity that exists. And notice that basically, so if we plug in negative x, right, finding f of negative x here, using this identity, this is equal to negative sine of x, which is the same as negative f of x, right? And so from this identity, we can see that this function is odd. Again, though, we're going to be working more with identities in a later unit. When you get something like this, you more so have to just see it graphically with the current knowledge that you have up until this point. All right, so sine x, it's the parent sine x function, not if it's transformed. If it's transformed, it doesn't necessarily have to be odd, right? If it's like shifted left or right or up or down, it's no longer going to be odd. It can be vertically stretched or compressed, like if we had a 4 here, it would still be odd. But if there's any translations going on, then it's no longer odd. But the parent function sine x is always odd. And then, I mean, while we're at it, let's just talk about cos x quickly. Cos x is an even function, the parent function cos x, because the way cos x looks like is it starts at the maximum, goes down like this, and so you could tell from the graph it's symmetrical about the y-axis, right? If I take this half of the graph, reflect it over the y-axis, I'd get the other half. So cos x is, the parent function cos x is an even function, sine x is an odd function. And that's a wrap for the video. Hopefully you enjoyed that. If you want to see more videos like this, please go to my website, allthingsmathematics.com. Over there, all of the videos are organized by chapter, by section. If you feel like you need tutoring at any point, you could also hit me up. My contact details are on the website. Enjoy your day, and I'll see you in the next one. Peace out.